For this video, we're going to talk about solving quadratic inequalities. Now, in previous videos, we've talked about the quadratic functions here, y equals ax squared plus bx plus c, and these really aren't going to change how they look. It's still going to be ax squared plus bx plus c. What is going to change here is that we're no longer going to have an equal sign. We're going to replace it with either a less than or equal to, greater than, or greater than or equal to, making these inequalities. When we are graphing these inequalities, a lot of the stuff we've done in the past is going to stay exactly the same, but there are a few changes we're going to have to be aware of in order to do these correctly. So it'll be easiest to see some examples, so why don't we jump right in. So here we have the inequality y is less than negative 3x squared minus 6x minus 7. We're going to want to graph this function so we can solve the inequality. But to start with, we're going to find the y-intercept. If you remember from a previous video, the y-intercept happens when x is 0. So if I put zeros in both of those x's, we're going to have a negative 7. So the y-intercept happens at 0, negative 7, and I can put that in our graph over here. There's my y-intercept. Now I want to find the vertex. Remember, the vertex is found by taking the opposite of b, dividing it by 2a, taking whatever x value you get from that, and putting it into the original function. So, b, in our example here, is a negative 6, and a is a negative 3. So the opposite of b is a positive 6, divided by 2 times negative 3, which is 6 over negative 6, or a negative 1. So right now we know our vertex starts at a negative 1. We need to get the y value for our vertex. So we're going to take that negative 1 and we're going to plug it into the original function. Negative 1 squared is positive 1 times negative 3 gets us a negative 3 minus, 6 times negative 1 is a negative 6 minus 7. Subtracting a negative 6 is the same as addition, so I have negative 3 plus 6, which is 3, and 3 minus 7, which is a negative 4. And there is our vertex. We are at negative 1, negative 4. So we have found 2 points here. We have our vertex, and we have our y-intercept. Now, since we know that this is symmetrical, remember our quadratic equations are symmetrical, if I go over to the right one and I'm suddenly at negative 7, that means if I go over to the left one, being symmetrical means I will also be at negative 7. And I have enough points now to create my parabola. I can connect the vertex on both sides, and I can get my parabola shape. But I don't want to graph it just yet, because unlike when it's equals here, this is less than. And if you remember how we graphed lines when it's less than, parabolas go the same way. Less than or greater than get dashed lines. Less than or equal to, greater than or equal to, get solid lines. So since I have less than, I'm going to have to make a dashed line connecting to make my parabola. And now that is not the only thing left. The last thing we need to do is to decide where to shade. Because whenever we are graphing with an inequality, there's going to be shading involved. We're either going to shade inside the shape or outside the shape. And the best way to do that is to check the origin. If I put zeros in for x and y, that'll give me 0 is less than -7. Is that a true statement? Is 0 smaller than -7? And hopefully you say, no, it is not. So because the origin did not work, the origin was not one of the solutions, that means the solutions have to be inside our parabola. And we will shade everything inside here. And that is our solution for our graph. Now, there's a lot of things that went on here. So let's recap. We took the original function, y is less than -3x squared minus 6x minus 7. We started by finding the y-intercept, plugging in 0 for x's. Then we found the vertex using our little vertex formulas here. Once I had that little vertex and the y-intercept, I counted over 1 to get us to the y-intercept, which was -7. So if I go to the right one and I'm at -7, I can go to the left one and also be at -7 because my graph is symmetrical. From here, I looked at the inequality. It was less than. So I knew I needed a dashed line instead of a solid line. And then I tested the origin, 0, 0. I put 0 in for y and 0 in for our x's, and that gave me 0 is less than -7. Since that was not a true statement, 0, 0 is not a solution, so everything inside would be a solution. Alright, we'll try another example just to get a little more practice, but hopefully this is making some sense. So let's try another one. For our second example here, we have the function x squared minus 4x plus 1 is greater than 6. This is a little bit different because we don't see a y here. But to start off with, whenever we are trying to solve our quadratic inequalities, we want one side to be 0. So the fact that I have x squared minus 4x plus 1 is greater than 6, I'm going to either have to make the left side equal to 0 or the right side equal to 0. And I think we would all agree it'd be easiest to get rid of that 6 through subtraction. So we're going to subtract 6, and we're going to have x squared minus 4x minus 5 is greater than 0. Now we want to figure out the x values that make this true. When are we going to be bigger than 0? So it's a little bit different this time, but we're still going to graph. So let's start just like we did before. Let's get our y-intercept. And for the y-intercept, I'm not going to pay attention to the 0. I'm just going to pay attention to the left side where our variables are. And I'm going to plug x in, I'm going to plug 0 in for x. If I plug 0 in, I get -5. So my y-intercept is going to be 0, -5. So it's going to be all the way down there. Okay, now I'm going to find my vertex. Opposite of b, here our b is a -4, so the opposite of -4 is a +4 divided by 2a, where a is 1 this time. That gives us 4 over 2, which is just 2. So my vertex is starting at the point 2, and if I plug 2 into the rest of this, I'd have 2 squared, which is 4, minus 4 times 2, which is 8, minus 5, and that's going to give us a -4 minus 5, which is a -9. Okay. So let's put our vertex into the graph. We are going over 2, and then down the rest of the way to -9. And there we have our vertex. Next, if I'm at 2, -9, and I go to the left 2, and now I'm at -5, that means going to the right 2 is also going to put me at -5 thanks to symmetry. And now we can create the general shape of our quadratic. It is greater than, so I want to make sure that I use a dashed line again. And here's where things are going to be a little bit different. I want to know, when is the graph greater than 0? So I'm trying to figure out, when is it up here? What values of x give us greater than 0? Because all of this underneath here is less than 0. All of these would give us negative numbers. We want to be greater than 0. And to figure that out, what we are going to do is return to the original function, x squared minus 4x minus 5. With the original function, we're going to factor it. We can use the diamond method. Yes, the diamond method hasn't gone away. So the diamond method, we've got a times c up top, so that's a -5, all over b, which is a -4. I need two numbers that multiply to -5 but add to -4, and that's a 1 and a -5. So we have x plus 1 and x minus 5 as our factors. So our zeros that we care about are x equals -1 and x equals +5. These are the spots on the graph where we touch zeros. And we can see that, these are the spots on the graph where we touch the x-axis. There are zeros. We can see from these points, oh, I'm above the x-axis to the left of it, and I'm above the x-axis to the right of 5. So if I want to be greater than 0, I need to be smaller than -1 or bigger than +5. And those are the solutions here. We want x to be less than -1 or x to be greater than 5. And that is our solution here. Alright, we'll try one more like this because I feel like we kind of took a roundabout way to do this. I'll show you how to do it just a little bit more efficiently. But then that's going to be it for this video. So let's try one more example. Okay, for our last example here, we have x squared minus 6x plus 10 is greater than or equal to 2. I'm going to show you how to solve this inequality without having to graph this time. We're going to go strictly algebraically. The first step, like we did before, is still get 0 on one side. So we're going to subtract 2 from both sides. That gives us x squared minus 6x plus 8 is greater than or equal to 0. From this step, we need to factor, like we did towards the end of that last problem. I can use the diamond method. A times c is 1 times 8, so I have 8. B is a -6, and I need two numbers that multiply to 8 but add to a -6. And hopefully you're saying -2 and -4. So I have x minus 2 and x minus 4 greater than or equal to 0. Now that we have this part, we know that 2 is going to give me 0, and we know that 4 is going to give me 0. So we have to check and see how do we behave, or how does the function behave when we are bigger than 2, x, or smaller than 2, when we are bigger than 4, and when we are smaller than 4. And you might notice that being bigger than 2 could also be smaller than 4. So if we're smart, we can choose specific numbers. Specifically, I'm going to test 0 because 0 is less than 2. I'm going to test 3 because 3 is bigger than 2 but also smaller than 4. And I'm also going to test 5 because 5 is bigger than 4. And we're going to see what happens at these points. Is the output positive or negative? We want positive because we want to be greater than or equal to 0. So let's see what happens here. If I plug 0 in here, I get a negative 2 times a negative 4, which equals a positive 8. So this is good. We know that using 0, or being less than 2, makes us bigger than or equal to 0. Now let's try 3. If I put a 3 in there, I get 3 minus 2, which is 1, times 3 minus 4, which is a negative 1. That gives me a negative 1 as my answer. Negative 1 is not greater than or equal to 0. So 3 does not work. So I know that I can't be bigger than 2, and I can't be smaller than 4. Finally, let's try 5. If I plug in 5, I get 5 minus 2, which is 3, and 5 minus 4, which is 1. And that's going to give us a positive 1. So 5 works, meaning we can be bigger than 4. All right, we have our solutions now. We have the solution of x being less than or equal to 2. I'll talk about why we add that or equal sign now. And x is greater than or equal to 4. The reason why we put that little equal sign in now is because 2 and 4 were the zeros of our function. They gave us 0. And since we're told we can be equal to 0, we can include 2 and 4 in our solution sets. So x less than or equal to 2 and x greater than or equal to 4 are our solutions. And that is it for this video. Hopefully you found it useful solving quadratic inequalities. Good luck.